Welcome to a lesson with Dr. Powell. Let's take a look at another example of the cover-up method where one of the factors, so both of them are linear, and such as so x minus 1, and let's do x plus 2 this time, and where one of these is, where this one is squared. Okay, and let's just do 1 again. All right, so how would this work? And it really doesn't have to be 1. I mean, I guess let's do x plus 1 just to kind of see how it would work. Okay, so we're going to do the cover up. Um, but before we do that, we need to know what the form is that this is going to split into, right? See how you have this times this. So it first splits up like this because these are parts that don't share common factors here like this. But then this part can split up like this, x minus 1 squared with a constant, and this part just had a constant all along. So you really have 3 different things. Now, unfortunately, we only have 2 things to cover up, but that means that we can quickly deduce what some of these constants are. In particular, the cover-up method will help us to find B and C really quickly, and then we just have to figure out what A is, which won't be too bad, because we know that this is equal to x plus 1 over x minus 1 quantity squared times x plus 2, and we can just plug something in to figure out what that coefficient A should be. How do you figure out what B is? Well, algebraically, you could multiply all the sides by x minus 1 quantity squared, and the only term on this side that won't have an x minus 1 at all in it will be this guy. You'll still have an x minus 1 over here. And so when you plug in 1, it'll be all these zeros over here except right here. Now over here, this would all cancel out, and you could plug in 1 now over here, which would be great. So it's like you're covering up again. So x minus 1 squared, this whole part, you can actually get that coefficient right there just simply by covering this portion up and plugging in what makes it 0, which is 1. So plug in 1, you're going to get 1 plus 1, which is 2, all over 1 plus 2, which is 3. So we get 2/3. So that means that B is actually 2/3. What's C? You can get C by now covering up x plus 2 in a similar fashion to what we were just doing over here. It's the highest power of its kind, and so the cover-up method will yield its result. So let's plug in -2, not to this part, but to the rest of it, covering this, pretending it's not there. -2 plus 1 is -1 all over -2 minus 1, which is -3 squared, so 9. And we have -1/9, right? Yeah, so -1/9. So C is -1 over 9. Okay, yeah, -1 over 9. Okay, so we have this guy and this guy. Now all we have to do is figure out what that A is. How do you figure out what the A is? Well, just plug in something simple that might make this computation work well. Let's see, 0 maybe would be good, but I'm thinking, yeah, maybe, let's see, is 2 okay? 2 might be okay as well. Because if you plug in 2, then so you plug in x equals 2, that makes this denominator 1, and this denominator 1 as well. So then you'd have A plus 2/3. So this is at x equals 2 plus, and then you have but you have a -1/9 divided by a 4th, which is like, so you have -1 over 9 times 4, which is 36. And that's going to be equal to, if you plug 2 in, this guy is just 1. Top here is 3, and the bottom here is 2 plus 2, which is 4, so 3/4. So I guess there's some fractions involved still, but nonetheless, we can still figure out what A is. If in particular we make a common denominator of 36 here, so multiply this 3 by 12 and 2 by 12 is 24 over 36 plus negative 1 over 36 is equal to now 9, right? So 27 over 36, because multiply top and bottom here by 9. And okay, and then what we get is, and we can multiply, let's see, hold, and that's A, right? A plus all of that. So this would be 23 and subtract 23 over, so we get 4 over 36, which would be 1/9. So A is actually going to be positive 1/9. Okay, so we're able to figure out what that is. Now, you can go through and integrate this using a u substitution right here and natural logs here. So 1/9 natural log absolute value of x minus 1. Here, a u substitution, a simple one with the u here, which is dx is equal to du in this particular case. So we get, and u to the negative 2 has antiderivative negative u to the negative 1. So this would be minus 2/3 times 1 over x minus 1. And then we have, because that's what u is x minus 1, then here this would be minus 1/9 times the natural log of the absolute value of x plus 2. That's plus c. So we just successfully integrated this by using the cover-up method, even though this power was higher than just a 1 right here. We use the cover method to get these coefficients right here, the highest power of the kind of that we see here of the two separate distinct parts here, this and this, and that then we had to work on this one, which wasn't too bad, by just plugging something in. And I think we're good. Thanks for watching.